which means this is going to multiply with what? N, the power that we are having there. Multiply this by b to the power n. Simplify this, simply going to give you a to the power m n times b to the power n. Always remember that we can play around with this. I can also rewrite this, or I can play around with it again and say a to the power nothing times b to the power m, multiply by, or everything raised to the power n there. Now I can rewrite this as a to the power n multiplied by b to the power mn, because mn is raising, b is raised to the power m, and now it's also raised to the power n, so we multiply the exponents there. Okay, let's have an example on that so that we make the life easy for some of us who are trying to understand math. Okay, so here let's have let's say 2 to the power 2 times 3, everything raised to the power 2. This is simple now that we know the rules. So this is going to be 2 to the power 2 multiplied by 2 times 3 to the power 2, which is simple stuff, isn't it? Now we know this is 2 to the power 4 times 3 to the power 2. You can then simplify that. Or I can have 2 times 3 to the power 2, everything raised to the power 2. This is simple. I now know that this is 2 to the power 2, this 2 raising that 2, multiply by 3 to the power 2 that we already have and raised to another power 2. So this becomes 2 to the power 2 multiplied by 3 to the power 4. Okay, simple stuff. Let's have law number 6 or rule number 6. I don't like calling them laws because now when we say law, it has to be definite. Let's call them rules. Okay, so a over b raised to the power n. This is division again, so we can rewrite this as a to the power n raised to the, then b to divide by b to the power n. But now things to note here, the bases are not the same, so you cannot then take this up and say a to the power b minus n. Don't make a mistake of saying if the bases are the same, then you raise the same powers and you try to subtract there. There is no subtraction happening because the bases are not the same. This is base A and this is base B. Okay, let's have an example there. So you notice that let's say 2 over 3 raised to the power 4. This is the same thing as saying 2 to the power 4 over 3 to the power 4, which is the same thing as saying, you can simplify that since now you know maths. You can punch that in the calculator or teach yourself, train your mind to deal with these exponents without using the calculator, because as we go on there are some that we're going to simplify without the use of a calculator. Okay, law number 7 or rule number 7, a to the power negative n. Now that is a negative exponent. So you notice that some of these problems, they would need you to rewrite this answer as a positive exponent. Whenever you've got this, what you simply do is rewrite as 1 over. So it becomes a reciprocal of a to the power n. So here, this law is simply telling you that you can rewrite a negative exponent as a positive exponent by introducing a division line there. Okay, for example, if I have, let's say, 2 to the power minus 4, I can rewrite this as 1 over 2 to the power 4. Simple stuff. Okay, now let's have the 8th, but this 8th law, normally I like to expand it into other things. Okay, so let's have it. So this one is a over b, everything raised to the power negative n. Things to note with this law. Things change a little bit here. So I'm having a over b to the power a over b raised to the power negative n. Now we want to make this positive, but things to note here, you notice that b becomes the numerator and a becomes the denominator, and the whole thing becomes positive exponent. So what I'm simply saying here is that b becomes the numerator, a becomes the base, and I now have the positive exponent. Things to remember: a times b has to be greater than 0. Okay, also remember, because if you say a times b has to be greater than 0, if one of them is 0 here, this whole thing becomes undefined. Remember, if you put 0 there and this is a number, becomes undefined. Okay, so make sure that if I divide by 0, let's say b is 0, this number becomes undefined. But let's say I have 0 there, this one number becomes 0, and if I raise an exponent to the negative 0, remember it says it becomes undefined. So when you're dealing with exponents, always remember any number raised to the power 0 is 1, except 1 or other than 1 itself, because once you raise a number to a 0, it becomes undefined. So make sure that in this case, when you're dealing with a and b, or when you're dividing with the negative exponents, or whenever you're dividing, make sure that the number that you have inside the bracket does not give you 0 at the end of the day. So in this case, a times b has to be greater than 0 or less than 0 in that case. Okay, so let's have an example and see how we can deal with this problem before we go to real examples. Okay, so let's have an example, a simple one. Let's say just say 2 over 3 raised to the power, let's put minus 3 there. So we can now rewrite this as 3 over 2, the denominator becomes the numerator and the numerator becomes the denominator, and this exponent becomes 3, not negative anymore. Then you can now simplify. 3 to the power 3 is your 27, and 3 to the power 2 is your 8 there. Then you do the whole thing. Okay, so I can also rewrite. Let's say I have, it's the same law. I have 1 over a to the power negative n. I can now rewrite this as a to the power minus 1 from the previous law, remember? So I can rewrite this, because remember, this is to avoid a negative exponent. So if I bring a on top, it's going to be negative there. But remember, I still raised this to the power negative n. But remember what we said: if we raise the power to another power, we can simplify this into a to the power minus times the minus gonna give me positive, so this is going to be to the power n. So I can get rid of the negative sign like that. For example, if I have got let's say I've got 1 over 2 to the power minus 4, I can rewrite this as 2 to the power minus 1 multiplied by negative, so the power of negative 4 there. So at the end of the day, what do I have? I simply have minus times the minus give me positive. 1 times 4 is still a 4. So I end up having 2 to the power 4. Okay, which is then equal to 16. I don't know if I'm right. Of course I'm right. Okay, so this is what we're going to follow when we're dealing with exponents. Also note that a square root, we can refer to it as a set. Okay, so we can also talk of the square root sign as a set or radical. So this square root sign is going to be very, very important. You can call it, whenever you see this, we are talking of radicals. Okay, these radicals are important when we're dealing with sets. Okay, when you're dealing with sets, so we're gonna have set equations, gonna deal with expressions that involve sets. For example, a set is simply a number. Let's just say if I ask you to find the square root of 2, you can't find that, so we then call this a set. Okay, so this number, we cannot simplify the square root of 2 without the use of your calculator, and it's going to give you a decimal fraction there. So in this case, we leave it like this and call it a set. Another example, I can have a square root or a cube root. Let's have a cube root of 10. this is going to give me commas again, so it's going to give me commas. So to make it easy in our calculations, we simply call it a set. We leave it there. Or I can have a cube root of let's say 31. A cube root of 31, you see, at the end of the day is going to give me some commas there. So whenever we have something like this, leave it as a set. This is what we mean when we say leave it as a set. Okay, now that we have all these laws that or rules that govern exponents, let's try and solve some problems, some real life problems that we're going to encounter in our tests and exams. So let's have example number 1. Example number 1. Okay, so this example is simply 2x to the power minus 2 raised to the power 3. I'll divide by, let's say it's 2x minus 3 raised to the power 4. So this type of a problem, it will come with an instruction which says simplify. So your job here is to simplify this problem. Okay, to simplify this, the first thing is do away with this bracket before you do away with that bracket. Then see if there's things that can cancel out. Okay, so before we use our laws, the first thing that I'm going to do here is get rid of the bracket. So how do I do that? I know 2 raise that to the power 3, x to the power minus 2, this is multiplying with 3 there. Then I'm going to divide this with 2 to the power 4, x to the power minus 3, then I'm going to multiply this with 4. Okay, so at the end of the day, what do I have? I have 2 to the power 3 multiplied by x to the power negative 6. Divide by 2 to the power 4 x to the power negative 12. Okay, now this is easy. You can use any other way of dealing with this. You can choose to divide it, or you can choose to add and subtract the exponents. So if I add the exponents, you know that I'll end up having 2 to the power 3 and 2 to the power 4, that there's the same base happening there, and I'm dividing. Okay, so I end up having 2 to the power 3 minus 4 x to the power minus 6. Since we are dividing here, it means this is 1 over, isn't it? So I end up having plus 12 there because of the divide sign there. So it means this is below because we are dividing. Remember, I can rewrite this as before. Let's simplify this, then I'll show you. So end up having 2 to the power minus 1 x to the power 6. Or we can rewrite this as 2 to the power 3 x to the power minus 6. Okay, everything over 2 to the power 4 x to the power negative 12. Okay, so here this and all that goes, then I remain with 2 to the power 1 there, then x to the power negative 6, all that goes, I remain with x to the power negative 6 down there. Okay, which then allows me to end up having 2 to the power or let's simply say 1 over 2 to the power 1 and x to the power negative 6. If I bring all this up, it end up being 2 to the power negative 1 x to the power 6. Simple stuff. Take a moment there and try and figure out what's going on. You might notice that you don't understand. Especially if you do not understand how to use this method, please try and use this.